Hello, I'm Doug Eicher, and I'd like to introduce you to the Joist Wizard. This tool analyzes your joist geometry and loading requirements to help you determine the most cost-effective joist depth for your project. It also helps you to estimate various properties of the joist, including weight, moment of inertia, and maximum allowable duct sizes. Let's jump in. All right, so we start off on the home screen of the tool, and right away you'll notice this Project Info tab on the right-hand side. So the first 4 fields of this are really just like header information. They're going to be used on the report that you generate at the end. So they're really optional. If you want to put them in, you can, but they're not required. Next, you'll notice we can select our units. So this tool supports both metric and imperial units. We have our design method, and then we have our design code, which is just going to be used to decide which load combinations to run during the analysis. Then we have a save record button. If you want to come back and view your work later, you can save a record, and we'll talk about how to do that here in just a second. Moving to kind of the rest of the inputs. Up here, this is blank right now, but as you're inputting information, this is going to populate with like a parametric joist view. So basically it'll show the basic geometry of the joist and all the loading that's applied to it in real time as you go. And then here under our specifications, we have some basic information about the joist. So we have our span, which is going to be that grid line to grid line dimension. If we have a situation where we need to limit how deep the joist is, we can specify depth limits, in which case it'll give you a minimum and maximum depth you can specify. We have our tributary width, which is going to be used to calculate the unit loading that's applied to the joist from the area loads that you input. And then we have our live load deflection limit. Next, we have our uniform loads. Right away, you'll notice there's this toggle here. If I have a situation where I have some more advanced loading, maybe I have a concentrated load or a drift load or something along those lines, I can come in here and select this toggle, and it'll take me to some more advanced input. And we'll get into that in just a minute. We have our basic uniform loads here, and then we also have this add self-weight option. So if you're in a situation where you don't want to have to include the self-weight of the joist and the bridging in your dead load, what you can do is select this, and in the background, the tool will calculate that weight as it's going through the analysis and apply it to the joist. Next, we have our uplift. So by default, the tool is going to assume gross uplift, but if you'd like to apply net uplift, you can do that as well. If you select gross uplift, the tool will run the net uplift calculation in the background, or if you select net, then it will just take that at face value. Okay, so let's take a look at our advanced mode. So I can switch to that with either one of these toggles, either the one down here or the one in the upper right-hand corner. Both of them will take me to the same place. If I click on that, now you'll see I have a few more inputs. So under our specifications, now I have this TCXL and TCXR. So if I want the top chord to extend past that grid line dimension on either end, I can input those here. I have a slope input as well if I have a sloped joist. And if I'm trying to meet a minimum stiffness criteria, I can input a minimum moment of inertia. Under my uniform loads, these look pretty similar to before, but now I just have a few more inputs. One thing you'll notice up front here is this dead reliable and dead collateral. So the difference between these two, they're virtually the same. But the difference between them is if I have gross uplift input, when the tool runs the net uplift calculation, it will only subtract the dead reliable load from the uplift, and it won't subtract the dead collateral. So in practicality, this would probably look like, for like the weight of your roof structure would be considered dead reliable load, and then anything hanging maybe on the bottom chord or light fixtures, things like that would be considered dead collateral because it's not necessarily permanent and might move around. We also have a rain load input. Now keep in mind, this tool does not do ponding analysis, so this rain load is just going to be applied as a basic uniform load. And then we have our downward wind input here as well. And then under the uplift, this is also pretty similar, but now we have the option for zonal uplift. So let's say you're in a situation where your joist is right at the transition zone between 2 uplift zones. What you can do is you can select this zonal uplift, and then it'll give you this option to input the magnitudes and then the start and lengths for each one of these different uplift zones. And now we get into some of the bigger pieces of this advanced mode. We have our distributed loads input. So this would be used for loads that either have like a differing start and end magnitude, or maybe they don't span the full length of the joist. So I can input those here. I also have concentrated loads. So if I want to apply those here, I have the option to input a magnitude and a location. And we also have this add load option. So this would be used in a situation where, say, maybe you have like a rooftop unit that you know is going to be applied via 2-point loads somewhere on the joist, but you don't know exactly where they're going to be. What you could do in that situation is you could take those two concentrated loads, you could sum the magnitudes, and then apply that as an add load to the joist. And then what would happen is when Vulcraft designs that joist, it will be checked for that load at every panel point. So that way, we know that the joist will be good regardless of where those loads are located along the length of the joist. Next, we have our axial loads. So if the joist is part of the lateral system, then we can input an axial load. You can select a top or bottom chord for that load to be transferred through. You can select a transfer method. So that's basically how the load gets into the joist and how it gets out. You can choose either joist seat or other. Just keep in mind that if you do select the joist seat, then there's some additional restrictions on the magnitude of load that can go through the joist seat. We can select a load type, so you can select wind or seismic, and then you can give a magnitude for your axial load. And then here at the bottom, we have our end moments. So if your joist is part of, say, like a moment frame where your bottom chords are welded to your column, you can add end moments to the joist. So here we can specify a moment type, whether it's gravity or lateral. So that would be like if your moment is being applied by your gravity loads versus by the lateral loads on your building. You can select an end for that moment. So if you want to apply it to the left or right end, you can select a transfer method. So either other or through the joist seat. And then you can select your load type. So just keep in mind that depending on what you input for the moment type over here, you will get differing options for your load type. And then lastly, you can input the magnitude for that. Okay, so now that we've walked through the various inputs, let's go ahead and let's go back to our basic mode. And just notice it'll bring up this little dialog that lets us know, hey, any advanced inputs that we gave are going to be cleared. So we'll go ahead and say yes. And then let's go ahead and just run a basic example. So we can do either metric or imperial units, but in this case, I'm just going to leave it at metric units. Let's go ahead and input a span. And then for our depth limits, let's go ahead and select yes. And you'll notice here that some values are pre-populated, and these are based on allowable span to depth ratios for the joist. So let's go ahead and leave our minimum depth where it's at, and let's put our max depth at 406 millimeters. For our tributary width, we'll give 1650. We'll leave our live load deflection limit where it is. And then for our uniform loads, we'll put our dead reliable at 0.75 kPa. And then we'll put our snow at 1.7 kPa. And then let's go ahead and enter 0.75 kPa for our gross uplift. And with that, let's run a design. Okay, so now we're here on the results page, and you'll notice right away that one of these is highlighted with this green bar. And that's just indicating that it's the most cost-effective option out of the different depths that it ran. So in this case, you can see that it ran two options, 356 millimeters and 406 millimeters. And so it's just highlighting this one as the most cost-effective option. So starting at the left-hand side here, we have our depth in millimeters. We have the cost ratio. And then we have our self-weight. So that's going to be the weight of the joist plus the weight of the bridging. And there's just a little note here to make sure that you've included the joist self-weight in the specified dead load that you've provided. We have our moment of inertia. And there's a note here just indicating these are estimates for the moment of inertia. So if you have a minimum requirement that you need to meet, you want to make sure to provide that to Vulcraft so we can design the joist accordingly. We have our live load deflection ratio. Again, we have a note indicating that these calculated deflections have been increased by 15% to account for shear deformation. We have our top chord width. So this is going to be the total width of the top chord. So the length of both angle legs plus the chord gap between them. we have our number of bridging rows, and then we have our max duct sizes. So these are estimates of the maximum size ductwork that can fit through the plane of the joist. And again, these are estimates, so if you have ductwork on your project, you want to make sure that you provide the actual duct sizes and locations to Vulcraft, and we can make sure to design the joist accordingly around that ductwork. We can also generate a report if we want to, which we'll walk through here in just a second. But first off, let's go back to our input screen, and let's take a look at our advanced mode. So let's say that we have slightly more complex loading requirements than what we had here. What we can do is we can click on this advanced mode, and you can go there either with this toggle or this one up here on the right-hand side. Either one will take you to the same place. Click on this toggle, and now you'll see we have a few different options to enter for our loading and our geometry inputs. So we'll come in here. Let's go ahead and take away our depth limits. So we're just going to go ahead and let it run wide open for the depth. We're going to leave our tributary width where it's at. But now we're going to go ahead and enter a top chord extension. So in our case, we'll enter 300 millimeters. And so now you'll see the diagram updating here on the left-hand side, that top chord extension. We'll add a slope, and then we'll leave our minimum I where it's at. For our uniform loads, let's change it up a little bit. We'll put in 0.3 kPa for the dead reliable, 0.75 for that dead collateral. Again, the distinction between those two is one is used in the net uplift calculation, the dead reliable, versus the other is not. Let's leave our snow where we are. Let's go ahead and input a downward wind load of 0.75 kPa. Let's check add self-weight. Let's leave our uplift where it is. So let's go ahead and input a distributed load. So let's say we have like a drift load. We'll select snow. For our starting magnitude, we'll go ahead and enter that. For end magnitude, we'll go to 0. Okay, and then we have our start location. So just something to keep in mind, if I were to say, put in the length of my load and then go up to the diagram and leave the start location at 0, you'd see how this load is actually starting not at the end of the TCX, but right here at the grid line dimension. And so in this case, we'd probably actually want it to start at the very end of the joist. And so the way that this works in this tool is everything to the right of that grid line dimension is a positive number, everything to the left is a negative number. So in my case, if I want to shift the load back, what I would have to do is come down here, and for my start location, I'll enter negative 300. And so now if I go back up to the top, I'll see that this load is shifted to the end of the TCX where I want it to be. Let's go ahead and enter a concentrated load. We'll leave it at the dead reliable. And then for our load magnitude, we'll put in 8 kilonewtons. For our location, we'll enter 5,550 millimeters. We'll go ahead and leave the add load option unchecked. Let's add an axial load. We'll leave the other inputs where they are. And then let's go ahead and enter our magnitude. And you'll notice if we go to the top now, that the diagram updates and we see that wind load here on the top chord, and we also see that concentrated load. And then one last thing, we're not going to worry about end moments for this case, but if we were to add an end moment, like say that we just put a magnitude in here, just so we can see it, if you scroll back to the top, you'll see that that moment is now shown on the diagram on the end of the joist where it's applied. But in this case, we're not going to worry about it, so we'll just set this magnitude to 0. All right, and then just so we can see how this looks on the report, let's go ahead and enter some identifying header information. So we'll just put in a project number. We'll put in a project name. A design mark, an engineer, and then we'll go ahead and leave everything else where it is. So let's go ahead and run our analysis. Okay, and so now you'll see everything looks pretty similar. Now we have a few more depth options because we let that run wide open. You will notice here at the top we have this note, and that's just indicating that since we chose to have the tool apply the joist self-weight, we'll need to make sure that we notify Vulcraft of what that self-weight is so that we can apply that correctly in our design. One other thing too, down here we have this equivalent uniform load section. So we don't actually recommend using equivalent uniform loads to specify the joist because there can be stress reversal issues with the joist webs in the center, and so it could cause the joist webs to be designed incorrectly. But this is just given so you have kind of a window into how the tool is estimating joist properties. So if I click here, I can see all the different load combinations that were run. And if I click on one of them, now I see the shear and moment diagrams for that particular load combination. And here you'll notice that we see a difference between the equivalent shear, which is shown by this blue line, and the actual shear, which is shown by this purple line here. And the same thing with the moment as well. And you'll notice that with each one of these, if I hover over it, it will show me the value at that particular location. Okay, so now let's go ahead and take a look at our report. If we click Generate Report and we select the depth we want and hit Generate, it'll spin for a second and it will generate a PDF. And so here we can see it just gives us a basic load diagram with all the load inputs that we gave. And then it will give us some basic project info and then also the results that we obtained from the analysis. And then if I want to come back later, so I want to save my work and come back later and change things, or maybe I want a colleague to take a look at my work, what I can do is click this Save Record button, and this will generate a record key for me. And if I click this button, it'll copy it to the clipboard. And what this will do is if I come back to the input screen and say we just refresh the tool, so we clear everything out, I can come back, I can click Load Project, I can drop in that record key and click Get Record. And so now you see all of those inputs populate in, so now I can come back and I don't have to start again from scratch. Okay, just a couple more things. We do have some additional pages. If you, say, have a question about the tool or about how it's analyzing something, you can click on this FAQ page. And in here we have quite a few frequently asked questions. And so if you're curious about something, you can click on that question and it will show you an answer here. And then we also have a technical revisions page. So if you want to follow along with how the tool is being updated, see what changed since the last version, you can click in here and you can see all those updates. And then lastly, we just have this licensing page, which is just for legal reasons, that shows the licensing for the different components that were used in the design of this tool. And that's the Joist Wizard, your go-to resource for determining the best joist option for your design. And with that, happy specifying.